good morning, good afternoon, good evening, depending on your time zone. Thank you very much for taking your time to join our talk on the effective business process improvement with or using process simulations. That's our topic today. My name is Michal Rosig. I'm working as a Chief Product Officer at Minit. So we'll have to start our talks about process intelligence, process mining with this life cycle, and you've probably seen it. And of course, we are starting with process analysis. So really looking at the data and getting the transparent view of your current assets processes. And based on that, leveraging the process mining functionalities and the power of that technology to suggest the different redefinitions or process reengineering changes that the enterprise might make in their processes. Of course, we have the topic of process monitoring, so continuously looking at the processes and seeing the KPIs and business rules. The compliance of the processes is, of course, very important. Many processes follow some regulations, laws, internal, external regulations, of course, and even some best practices. So compliance with your policies is very important. And of course, the process improvement, which closes that loop and goes back to the process analysis, because really analyzing the processes and optimizing them is an ongoing cycle. And we have looked at this life cycle many times in the webinars that we did, and we always found that the process mining field is more focused on the items number 1, 3, and 4. So process analysis or process discovery, process monitoring, and compliance. With the redefinition and improvement, these things have been left to the enterprise itself and to the people there to make the desired changes. Now, today I would like to talk about how process mining and the process intelligence, let's say, can help you to make those changes. When we talk about when we talk with enterprises about process mining, process mining, as you heard in the previous talks, is based on the past data. So we take the event logs, we take something that already happened, and look at that data and show the results, show the as is state. Now, most of the enterprises give us immediately a following question, like how the future will look like. So they want to look at predictions. Can you predict whether I will fill some KPIs, whether my process will end up good or bad, or the outcome would be positive or negative? So the predictions are looking at the past. They are learning from the past, of course. The models are being taught with the past data. Then they are leveraging the existing process models. So when you analyze an event log and you get an as is state, that data is loaded into the models for predictions, and the predictions are based on this existing process model. And then as a result, you can have a look at how the processes or the process instances will, with a certain probability, behave in the future. So whether my process will go to the left or right, whether my KPI for delivering the goods in my process will be met. But this takes us back to the process lifecycle, and we are kind of, when looking at the predictions, we are kind of omitting or we do not find this process redefinition there. So as we've seen in the poll, the process optimization done beforehand will in the most cases lead to a better result. Just using the predictions on the existing data with the existing process model might not work well if the process is not optimized enough. So there is one thing about predictions that kind of makes a point, and that no changes have been made so far. So we are in many cases looking at predicting the future based on the data where no changes have been made. And of course, in some enterprises, the processes are running well, and you can do that prediction. But in most cases, there's always an optimization or change that can be done to have better results for the processes. So let's look at process reengineering and the different types of process reengineering or redefinition. Now, when we talk about this, again, with the customers, the first thing that comes to their mind is that now we have to change our process. You will tell us that we need to do the whole process in a different way. But that's not always true. There are many, many types of process reengineering based on the process intelligence or process mining analysis. Not only changes to the process model. First of all, we are talking about changes to infrastructure. And here we are talking about software and hardware used in the enterprise. So we are talking about networking. We can speed up the processes just by looking at how the different servers, systems, and computers are connected. We can look at leveraging cloud infrastructure for better scalability, for reducing costs based on the cloud instead of on premises. We can look at new and modified IT systems. So maybe the systems that are used in the process that we have the event logs from are not the right choice for that process. And of course, performance boost. Sometimes the systems are used in an infrastructure that is slow, and all the operations that the users have to make in that process are just taking too much time and kind of slowing down the process. The next area is we can look at the changes to organization as itself. Management reorganization, how people are managed from a line perspective, from a project-based perspective, depending on your industry and your type of processes. We can look at the redefinition of responsibilities. Process mining can show you in a social chart interaction between different people or teams or divisions or departments. It can show you how the different checks and 4i controls are met or not met, and who is responsible for activities performed in that process. And basically, you can just by redefining the responsibilities of individual people change the process outcome. And of course, changes to the organizational structure. So sometimes it might be beneficial to reorganize teams in a department, reorganize departments, even with companies that go across multiple regions or multiple countries. It is very beneficial to look at the organizational structure. And I hope in the live demo, we will look at the organizational structure and how we help to mine the organizational structure with our tool as well. Of course, there are employee-related changes, and that's training. So many times we have seen processes where we assessed or evaluated different human resources and users of different systems or members of those processes based on their performance. And sometimes we've seen examples where from the viewpoint of simple process mining technology, the low-performing people or employees, where the duration of the activities for them was the longest, were just the best people in that team, and because they have been assigned the most complex tasks, and therefore the duration of those tasks or activities have been long. But for those who are low performing or it might not mean that you are going to fire them. It might mean also that with a proper training, with a proper education, you can speed up their performance in the enterprise. Of course, workload reduction. You can clearly see from the process maps, from the process mining tools, that how the people are overloaded with different tasks and activities. The animations in process mining tools show you where are the bottlenecks, where the waiting time for resources on certain activities is just long, and you're waiting because those resources are overloaded. Team enlargement, of course, adding different people to those teams. We will see that also in the simulation demo. And team enrichment with different skills, or people with different education, or skills and trainings. And lastly, we have the process model redefinition. So the existing process model might not be really the best. And here we have several points. Robotic process automation might redefine the process model. Of course, we might find activities that we want to skip, that we want to leave from the process, and the process allows us to leave those activities out. Error reduction via additional checks and controls. So activities might be skipped, but there might be activities that are added to the process, because not only performance is something for improvement, but also the outcome of the process. Sometimes errors are made, many rework loops are done in the processes just because of human errors. And additional checks, changing the process model by adding activities might help in the error reduction. And we have the process variant rerouting. So that's another point where routes in the process are taken based on some criteria. So, for example, you have an purchase order approval process where for the purchase orders about 10,000 euros, you take a certain route in the process. But changing that maybe to 5,000 or maybe to a higher number, depending on your process, might speed up the process because you do not go into big risk with errors, and you are skipping several steps of approvals for that particular purchase order. So if we are looking at these different reengineering types, what we can see is that there are many decisions to be made when talking about process optimization and process improvement. And these decisions are made by the process owners or the management based on the outcome of process mining analysis. And before the decisions are made, there is one question that comes very often, and that's what if. So before making a decision, my question would be, what if I make this choice? What if I choose this optimization? Would that help? Would that speed up my process or not? And there are many scenarios. So what would happen if we had a bigger team in the accounting department? Or how much cost would we save if we had 3 RPA bots taking over a certain manual activity? Would the customer journey be faster if we reroute the returning orders to bypass certain activities? So all these what-if scenarios are something that are, making the decisions longer. And the managers and process owners always want to decide with data, and we are missing that kind of answers to the what-if questions in that data. So what those people would like to have is something like a parallel decision universes, something where they do not have the fear of failure in making the right decision, because they can look at the decision beforehand and outcome of the decision. They would like to have something like a decision sandbox where they can play, something like a twin of the company where they can make the decision and see how the process behaves. And of course, look at the decision costs. Would it, with the redefinition of the process, there is always cost of doing the redefinition. Would the outcome and the cost reduction be on the same level or even bigger? And of course, to for the top management, the decision must be justified, and it's always better if it's justified based on data than on some kind of guesses. So we are coming to the point of simulation. We would like to have simulation present, and we would like to make these decisions on the mind models to see the potential of the decisions in the process reengineering. And Minit brings the simulations into the toolbox. And I would like to talk a little bit about the simulation principles. And the principles that we use are the same as we use for the whole Minit application. So we are using a scalable simulation engine that is based on an academic research in the field. Based on the research done by people with process mining background, with simulation engine background, we are leveraging the cloud power. The simulation engine is running in the cloud. It's enterprise with enterprise scalability, so it automatically scales based on the number of the requests or load. So no matter how heavy your simulation might be, we can leverage the power of the scalability of the cloud to satisfy our needs. And we offer the whole process model reengineering as we talked about it before. So we offer the changes to make the changes in the process environment. So looking at the arrival rate of the processes, how the processes start, when do they happen, looking at the different resource teams and resource groups, what is the number of the resources, cost of the resources, process resource changes, so you can create new resources, you can leverage RPA bots in that simulation. And of course, the whole process model modifications. So you can change the model any way you want, and just try this in this sandbox, many different what-if scenarios that you are interested in. So if we look at the process, we offer the ability to change the starting point of the process. So arrival rate distribution, whether it is fixed, whether it is very uniform, whether it is a normal distribution or a triangular distribution, exponential distribution, all the distributions that you see in that slide are offered. We have also plans for the next versions where we are adding this kind of functionalities to the simulation engine. We'll leverage the calendar template, so you can simulate even using your custom calendar templates, defining the different working hours than in the mind models, and using this simulation with that. You can have a look at the resource teams and resource groups. As I said, changing the number of resources in the particular team, performing a particular activity, and changing the costs for man hours for those teams. We look at the middle of the process where the activities are done. Offer full model editing with a BPMN-based editor. So based on the mind model, which is in our case directly follows graph, we discover a BPMN model and give you a full functionality of a BPMN-based editor where you can add different gateways, activities, different routes, delete the activities, and so on, assign resources and assign costs. And of course, we are looking at routing probabilities as well. So on the individual gateways, we allow you to define what is the probability of taking a certain path in the process. All the data that is in that model or in that simulation model before running the simulation is taken from the mind model. So you have all the results from your process mining project directly taken into the simulation, preset, and you can change whatever you want in the model. And we are looking also at the individual activities and allow you to assign the resources to the activities, give you the possibility to assign different duration distributions. So we know that in some cases, the durations are using a normal distribution. Sometimes, for example, with the RPA bots, the distribution is more like fixed, or with a smaller variability. We allow you to assign fixed costs and also cost thresholds and duration thresholds, so you can monitor your execution of the simulation. Okay, but that was just talking about the simulations. Now let's have a look at how this looks like in real life. So let me share the screen and walk you through the simulation module in Minit. So I hope you can see the screen. I think yes, wonderful. So here we are in Minit Project Hub. I have prepared the project with the simulation module running. We have a simple process imported. That's a credit approval process. Where we receive a credit application, we have two tasks that are done, and that's checking the income sources of the applicant, or checking the credit history of the applicant. So approximately half of the cases just go to the check income sources, half of them go to check credit history. We are looking here at the frequential analysis. Then they assess the application, make credit offer, sometimes, and of course, receive a customer feedback for that offer. Sometimes there is a loop. So Minit allows you to look at, of course, the performance of that process from a viewpoint of activities or waiting times. Of course, we have the financial attributes for the individual resources performing the activity. So when we look at the details of that activity, we can see what is the cost of that activity based on the man hours and the duration of the activity. And of course, we have the resources that are performing that activity here, and what is the percentage of how they perform the individual tasks. Of course, we can look at it from the viewpoint of rework. As you can see, rework is a special metric or set of metrics that show you where are the rework and rework loops in the process. So the red one, the red activity, is basically the one that is responsible for generating the loops. That's receiving the customer feedback. So in several cases, based on the customer feedback, we need to make a different offer and assess the application again. So there are several loops. Of course, we can then look at the variance of that process and see that. And making the credit offer is the one that is responsible for exiting the loops. So we are seeing the net loop gain on the individual activities and the rework count on the edges. If we look at the financial attributes, we can see the individual costs for the activities. Of course, we can look at the process also from the hierarchical point of view, and we've shown, so if you are interested in seeing, for example, how the hierarchical maps that we have in Minit can help you with finding the right RPA candidates or monitoring the processes, the end-to-end processes, leveraging bots in certain activities, you can jump to a webinar that we did with Rochelle several weeks ago. So I will not go into much details, but the hierarchy can be used also not only in the looking at the bot and the structure of the bot or user interaction recording, but also the organizational structure. So we can look at the process from a viewpoint of a bank giving this credits, and drill down into the organizational structure, just focusing on the performance of the individual here divisions, and then go deeper into the departments, the administration department, backend processing, that we see we have some potential bottlenecks there. And if we look at the administration, we can see that the check credit history and check income sources are the tasks that can be probably automated with an RPA, but they are taking a lot of time in that process. And of course, we have some potential bottlenecks here at the backend processing with assessing the application as well. So in this way, you can leverage the hierarchies also for organizational mining. You can drill down into the organizational structure. You can look mostly in very complex processes at the like aggregated statistics for these particular departments or divisions. This can be also done in the social view. So if you are looking at the individual resources, how they are communicating, what is the I'd say a lag or gap between when the task is flowing from one human resource to a second one, and you can look at it as well on the level of organizational structure. The benefit of this is, of course, that the organizational structure or the attributes are mined automatically. They are suggested. You just build a hierarchy in the right order, and you are ready to go with map simplification and showing the statistics as well. And you can, of course, very easily expand it all or just switch it off depending on what you need to achieve. Now, okay, we have looked at the financial attributes here. Maybe we have one more question. What is the overall cost of our process? So we also have something new in Minit, and that's custom metrics, where you can define your own custom calculation. So let's add a custom metric here. And we want to know the process cost based on the resource rate and the duration of the individual activities. So we can write something like sum for all, where we want to have a resource rate multiplied by total hours from duration, and close that one. Yeah, formula is valid. Okay, I have one like that here. So let's do it like this. So now we can see on all the activities that the process cost for the whole process based on the durations and the resource rates is around 17,000 euros. So now we know that based on the other views on the process, we know that we would like to automate those two activities with bots. And now our question is, what if we do that? Would the cost be lower? Would the process be faster? There's one more thing. We can look at the statistics of that process. So we are looking at mean case duration around 46 minutes. Now the manager has to decide whether this makes sense, whether the investment into RPA and investment into this initiative makes sense or not. So how to answer that question? Well, we go into the simulation module and we create a new simulation. It's very easy to use. Simulation module has 3 tabs: simulation settings, BPM and process model, and simulation results. In the simulation settings, you give it a name, of course, and you can decide on importing the simulation log as a new Minit process. The simulation will generate the log and import it as a new process, so that you can compare it with the original. Or you can just go and get some simulation results where you see different charts and the tables for the individual activities and the overall costs, if that's sufficient for you. So just to be faster, we can leave that here. I already ran the simulation once with that imported. And now here we have the list of resources. That's human resources or system resources. We have different teams and the number of resources for that particular team doing a certain activity. So for example, for the assess application team, we have 3 resources, and we have 1 resource for the other teams. So we do not have the RPA bots here. That's why we add a new resource, and we create a bot fleet. Sorry. Fleet. We say we have 3 resources like that. And now we go to the second tab where we can change the whole process model and where we can assign those resources to the model. So as you can see, we generated a BPM and process model out of that process map that you've seen before. We have these 2 activities here. So we open the first one, check income sources, and here we assign that a bot fleet would perform this with different distributions, so not normal distribution, but fixed. Let's say it will take 2 seconds for the bot, and the cost for one run of the bot, there will be fixed costs of 50 cents. Save that, and we go to the check credit history, and we also automate that. And it's fixed, but with 4 seconds, it takes more time, but with the same amount of money for 1 run of the bot. Right. So there is an editing of the model available here. So if we look at model editing, you can even change the model. Well, that's a full BPMN editor where you can add gateways, add activities, annotations, and then boundary events, or remove the elements based on your needs. And of course, you can change the probabilities on the different gateways as well. So now it's time to run the simulation. To start, it's running as a asynchronous task. So as you could see for a small second, you can work with the application. If that simulation is taking more time, you can work with the application and just wait for the pop-up to come up, and then have a look at the results of your simulation. So as we can see here, we have simulated 500 process instances. We received the total cost of the process at 13,300 euros. So we see there is some reduction of about 3,000 euros in that process. The total simulation time, so meaning from the first activity till the last. Here's the distribution of the individual cases and their throughput time. Here's the instance cycle time. So we are at 0.6 hours here in this process, in this simulation, and you have a detailed also information about how many times the individual activities have taken place. So as you can see, the distribution, the probabilities are the same or approximately the same as in the original process, and the durations here as well. So now we can have a look at the imported process here, which is the result of the simulation I ran before. And of course, you can have a look if you remember the numbers, but that doesn't matter because we have the process comparison, and we can have a look and compare it with the original process. So immediately compare and see, this is the frequential analysis. So the number of, or the frequencies of the individual activities is pretty much the same, but have a look at the performance. And as we can see, we see the benefit in these 2 activities where we cut the activity duration by 19 minutes here and 10 minutes here, of course, with the bots. But the problem, there might be a bottleneck shift with the assess application, because as the bots are performing well and they produce more and more work for the people assessing the applications, there might be a bottleneck shift that those human resources, it will take more time for them to assess the application. But we have saved also some time on waiting times here for the receiving customer feedback and notify rejection. So if you look at the overall statistics, we are right now at 40 minutes with the mean case duration, and we have saved around 3,000 euros for the process. Now we can run the simulation once again. So that's very nice thing to do, that we can go again to the original process and just run the other simulation where we also look at the assessment team change. And here I will not go into much detail, just open the previous one. As you can see here, SS application team has been just enhanced from 3 resources to 5, and that is in the BPM and process model also reflected. And if you look at the simulation results, we are at 13,600, so the cost is a bit higher, but let's have a look at we can resimulate, because I don't have the log imported. So let's resimulate that one. So that's another nice feature, that also you do not need to create a new simulation again, but you can just use and leverage the existing simulation. You can duplicate them. You can come back to the simulations and change individual parameters and do resimulation. And as you can see, we have 13,377 as a total cost and around 0.7 hours for that process as an average time. All right. So now back to the presentation. So to sum up, what we have seen here, first of all, I tried to explain the difference between predictions, where we look at the future from a probability point of view based on the past data, versus the simulations, where we take the past data to load it into a simulation engine and trying to remodel or re-engineer the ASYS process and look at the different what-if scenarios. So basically repeat the past with different parameters. Look how the past would behave with different parameters. We have seen the importance of process reengineering, and you told us that in the poll as well, or in the poll answers, that process optimization and doing that before doing anything else, or any RPA initiatives or any other initiatives, is very important, because those changes are those that drive the improvement. Minit simulations give you immediate results on the level of process costs, on the level of process throughput changes, so you can immediately see what is changed with respect to costs of the process, or the duration of the process, or the leveraging of different resources. You can have a look at the activity details in the comparison view to see the precise statistics. And you have seen also that in the process simulation module, you have also access to the generated event log that is generating based on the simulation, and can be used in comparison with the original to see visually how the process behaves, to see potential bottleneck shifts, because that might occur, for example, in the hybrid processes where RPA is used. And of course, again, look at the activity details as well.